Welcome to the solution video of question number 2 of paper 3 TZ1 May-June 2022 IB Math AIHL. This question is about a metropolitan area council planning a new town and the location of a new toxic waste dump. A metropolitan area in a country is modeled as a square metropolitan area. It has 4 towns. Okay, 4 towns make up one metropolitan area. Located at the corners of a square, all units are in kilometers with the x coordinate representing the distance east and y distance north. 0 is one of the one. Okay, let me try to draw it here. So this is one town at 0 0. Yeah, they've shown it here 0 Hamilton H. And then at 040, do we have 040 we have Edison. That means y coordinate is 40, x coordinate is 0, and let's complete the square. Okay, so at 40 we have Fermi town. Let's call it F. 40, and then at 40 we have Gaussville. Okay, the model assumes that each town is positioned at a single point. Yes, this point represents each town. All right, describe possible circumstances in which this model assumption is reasonable. What are the conditions under which we can assume a town as a point? The reason, okay, could be that this town is very small. Okay, that could be one reason. Or most of the population is concentrated at one place. That's what could be a reason to assume this as a point. B. Sketch a VORNOI diagram showing these regions within metropolitan area that are closest to each town. So within metropolitan, that means we can't go beyond this square. So we have to draw vertical perpendicular bisector of EF and then perpendicular bisector of this. And okay, we can continue this here and here. This is the VORNOI diagram, but I will erase the one which is outside. This is within metropolitan area. So this is the VORNOI diagram we can talk about. Let me make the actual lines solid so that I differentiate between the perpendicular bisectors and actual lines joining the nodes. So what next? The next is this. The Metropolitan Area Council decides to build a new town called Isaacopolis located at 3020. Okay, 3020. That means 30 is somewhere here and 20 will be here. This is the point where a new town Isaacopolis, yeah, its coordinates will be 30 20. Okay, a new VORNOI diagram is to be created now to include Isaacopolis. The equation for the perpendicular bisector of IE, this one, this is the line, and the perpendicular bisector will be this. Okay, so let me undo this first. Let me draw the new VORNOI diagram. Let me copy this one first. It's here. Okay, and let me erase the one which was originally there because our VORNOI diagram will change. So now there will be a perpendicular bisector, they said. This is the equation of that perpendicular bisector of IE. So the perpendicular bisector will be somewhat like this. Okay, and this will cut the one which was originally there, so I think we should go up to here. Okay, find the equation of the perpendicular bisector of IF. IF. Okay, so the perpendicular bisector of that will be somewhat like this. So they say that find the equation of the perpendicular bisector, which is this one. We have to find its equation. Okay, to find the equation of any line, we should have y minus y1 equal to mx minus x1, or y equal to mx plus c like they have done here, but I will prefer this one. That means x1, y1 are the coordinates of the point on this particular line, perpendicular bisector, which will include the midpoint of IF. This is I, this is F. So midpoint will be somewhere here. So let's find x1, y1. So x1, y1 will be the midpoint of IF. So 30 plus 40 divided by 2. And 20 and 40 divided by 2. This will be the midpoint, which is 35. 70 divided by 35 and 60 divided by 2, 30. 35, 30 is the point which is on the perpendicular bisector. So we can write here y minus, what is y? 30 equal to, m we'll just find out, but x minus 35. Okay, let's talk about m now. The gradient. Gradient of this line is unknown to us, but we can find the gradient of IF. So gradient of IF will be y2 minus y1. 40 minus 20 divided by x2 minus x1. 40 minus 30. Which is 20 divided by 10, which is 2. Yeah, 2. But this is not the gradient of the line we are looking for. This equation is for the perpendicular bisector. So we will use the negative reciprocal of 2, which is negative half. Okay, so let's open the bracket now. Y minus 30 equal to negative half x plus 35 over 2. And let's bring in this format, let's bring 30 here. So y equal to negative half x plus 35 over 2 plus 30, which comes out to be negative half x. Now let's write negative later. First write the number which is positive. So it will be how much? 60 plus 30, 95 over 2 minus half x. This is the equation of the perpendicular bisector of IF. Given that the coordinates of one vertex of the new Voronoi diagram are 20, 37.5. 20 is in middle point here, 37.5 somewhere here. Okay, that means what I drew was not perfect. It is passing through this particular place. Okay, so let me erase and correct it. It was just an assumption, the earlier one. Okay, so they are saying it is passing through how much? 20 and 37.5. So it will be line here, 20, 37.5. Okay. Find the coordinates of the other two vertices within the metropolitan area. That means not outside, but within metropolitan area. Okay. So basically it will be a reflection here again, and again this way and this way. Oh, a pentagon we will get. Okay. So we have to find the coordinate of this point and this point. Two more, right? This other two vertices. So we know that this particular point has an y coordinate of 20. We know this, right? Only challenge is to find the x coordinate. What is the x coordinate of this? But they have given this equation, the perpendicular bisector of IE. I is here, E is here. This is the perpendicular bisector. The equation of this line they have given already. Y equation, let me write, equation of perpendicular bisector of IE is y equal to 3 over 2 plus 15 over 2. Okay, x is here. So we know that here y coordinate is 20. So let's put 20 here. 20 equal to let's say 1.5x. Okay, I'm trying to make it simple with the decimals. Plus 7.5. So it goes there. 12.5, 20 minus 7.5 equal to 1.5x. That comes out to be 12.5 equal to 1.5x. Divide 1.5 here, 1.5 here, and we get 12.5 divided by this thing. So which comes out to be 25 over 3. So the coordinates of this point here are 25 over 3 and 20. Now we have to find the coordinates of this point. And this point is a reflection of this point downwards here. So we know x coordinate is already 20. We know this, right? It is exactly in middle. And since this point is 37.5, that means 2.5 lesser than 40. So it will be 2.5 above 0. So that means y coordinate is 2.5. So we got both the coordinates. Let me write them here. They are 25 over 3 comma 20 and 20 comma 2.5. Got those two coordinates. Sketch the new VORNOI diagram, which I have already done here. Alright, so let's move on to the next one. The metropolitan area is divided into districts based on new VORNOI regions found in part C. Okay, a car departs from a point due north of Hamilton. So I think I need a copy again. And here it is. Okay. So let me erase some parts out of this. I know the details. So 25 over 3, I erase this, I erase this. We'll focus only on VORNOI diagram. Okay. A car departs from the point due north of Hamilton. Okay. Due north of Hamilton here, from here somewhere. It travels due east. Okay, this way. At constant speed. That is good part. To a destination point due north of Goswell. Due north of Goswell. With what? Where is Goswell? Let's. I was 1. Okay. Goswell is this one. This is not Q. It is G. So here somewhere. Okay. It passes through the Edison Isopolis. Edison Isopolis. I was here, right? Somewhere here. Edison Isopolis. That means Edison is here. Okay, not that means our starting point is not here. It is here because it is going from Edison Metropolis and Isopolis here. This one also. So it goes this way. Okay. And Fermi town. Yes, it makes sense now. This is the real one. So let me draw it in different color. This is the route. Okay. The car spends 30% of the travel time in Isopolis district. This is Isopolis district. So this part from here till here is 30%. Okay. Of the travel time in the Isopolis district. Find the distance between Goswell and the car's destination point. Okay, so this distance is needed to be found out. This one. This is the destination. Let me call it D. And this is Goswell. So this distance is needed. That means we know total distance from, let's say this is a starting point S. So from S to D, we know that distance is 40 kilometers. Correct? And inside Isopolis is 30% of 40. That means 12 kilometers. This point and this point, between them the distance is 12 kilometers. If somehow we find the y coordinate of this particular point where it is on these 2 points, because the same y coordinate will be here, and I will subtract 0 from it because the y coordinate of G is 0. So whatever is y coordinate is the distance. Yes. So in other words, they're asking us to find the y coordinate of these 2 points. All right. And we know their equations. Let me copy those equations. They have written, they had given it y equal to 3 over 2x plus 15 over 2. Y equal to 3 over 2x plus 15 over 2, and then we got another one, y equal to 95 over 2 minus half x. Let me magnify this particular part. Okay, this is the line coming from top, this is going there, this is going here, and the distance from here to here is 12 kilometers, correct? If I equate this y and this y, we will get the x coordinate of this point, which we do not want. We want x coordinate of these ones when their y is same and their x values are 12 kilometers apart. So if this is x, which belongs to this line, this will be x plus 12, same x which is previously here, right? So now I will change the equation of this one, which will be 95 over 2 minus half x plus 12. Now their x's are comparable and they have same y. Now I can equate the two equations. So it will be 3 over 2 x plus 15 over 2, which is y. In this case, it will be equal to 95 over 2 minus half x plus 12. And let's find the x value. So x is 3 over 2, or x will stay here, and this minus half x will become plus half x on the left side, and then we have numbers here, 95 over 2. Then this 15 over 2 will also come to the right side, and then we have minus half times 12, which is minus 6. Okay, 3 over 2 and 1 over 2 will be 2x. Yeah, 4 over 2, which is 2x, equal to 95 minus 15 will be 80, divided by 2 is 40. 40 minus 6, 34. So x is 17. That means the coordinate here is 17. X coordinate. Y coordinate we'll find out. Here it will be 29 plus 17 plus 12, 29, right? Now let's find the y coordinate, which is actually our requirement here, so that we find y coordinate of this point as well, which is north of Gaussville. Okay, so let's use any one. We can use this formula, this equation. Y equal to 3 over 2 x, we got now 17 minus plus 15 over 2. So 17 times 3 is 51. Y equal to 51 over 2 plus 15 over 2, which is 66 over 2, or 33. Y coordinate of this point is 33, and this is 0, difference is 33, so 33 kilometers. That is the straight away answer. We can write that the destination is 33 kilometers north of G, Gaussville, I think. Yeah, Gaussville, yeah. Okay, we found it. Next, a toxic waste dump needs to be located within this metropolitan area, and that means I need the drawing again. Okay, here it is. The council wants to locate it as far as possible from the nearest town. Find the location of the toxic waste dump, given that this location is not on the edges. It cannot be on the edges. That means it has to be either here, here, or here, and we know the coordinates of all of them. So we have three options: 20, 37.5, or 25 over 320, or the third one, 20, 2.5. We know that these distances, these two, are exactly same. So let's find one of them. Then we'll find, okay, let's find this one, because same will be the distance this way. Let's find this, and from this as well. Okay, These four distances we'll find, and let's see which one is the farthest, because they said as far as possible from the nearest town. Okay, so we can use Pythagorean theorem in each case, isn't it? Or distance formula also. So let's use distance formula for this one. So this is, have I named it? No, I've not named it. So let's call it me A, there's no B anywhere, and this B and this C. So let me find all of them with distance formula. First I will find AE will be square root x2 minus x1. So 25 over 3 minus 0 square plus 20 minus 40 square. Similarly, I'll find BF, and I've already done AC, so HC and BI. Okay, I will cut this particular video, and then when I return back, I'll have the distances with me. And I'm back. Three distances came out to be same. This one between A and E, this distance was the farthest, which is 21.7. So A is the right position, which is 25 over 3 comma 20 is the best location for the dump. Okay, what next? The toxic waste dump T. Okay, so they're calling it not A anymore, they're calling it T. It's connected to the towns via a system of sewers. The connections are represented in the matrix, this one. So if you notice here, 1, 1, 1, the diagonal is 1. That means each town is connected within. So that's why it is written as 1. And it is connected with, let me write the towns here. E, F, G, H, I, and T is the dump. And here it will be E, F, G, H, I, and T. Let me try to visualize this. So this is our square where we have E, H, F, G, and T. Right? Now they're saying that E is connected with G because there is 1 here, and H. So let me connect E with G. That means it's a diagonal of this particular square, and E is also connected with H down there. So these sewer lines are there. Okay. F is connected with F itself, okay, and T. So F is connected with T, we can say like this. Is connected with F and T. Next, G is connected with the E. G is connected with E already, and is connected with itself, and I. So I was somewhere here, right? I was here. So it is connected with I as well. Okay. H is connected with E itself and T. H is connected with E and T. So T, there is a line, sewers line from here also. This is T. Okay, what about T? No, there is I Zocopolis also. So I is connected with G. I is connected with G. Yes, it is already there. I is connected with itself. That's it. T is connected with F, H, and T. T is connected with F, H, and itself. Yeah. So this is pretty much the sewage line. Okay. Now let's answer. A leak occurs from toxic waste dump and travels through sewage lines, these ones. Okay. The pollution takes 1 day to travel between locations that are directly connected. That means from E to G, even though the distance is very far, but it takes 1 day to reach from E to G. All right. The digit 1 in M represents the direct connection. We have already seen that. The values of 1 in the leading diagonals of M means that once a location is polluted, it stays polluted. That means it is connected with itself. That's what we have already interpreted. Find which town is last to be polluted. So if we can see from here, T, the the pollution will keep on going this. So one in the diagonal shows how many days it will take to reach the next one. So it is 1 day, this is the situation. So we should write m square for 2 days, m cube for 3 days, and m4 for 4 days. So I have already done this online and seen here. This is m square. If I square the matrix given, this is what we get, and this is last line is t. If you know, the last line is t, from where the leakage occurs. So in 2 days it pollutes the first town which was connected, and that town was E, and this town is still not polluted, this town is still not polluted. So we will go to m cube, which is 3. So we can see that this town is still not polluted. So we'll go to m4, and we can see this is mistakenly written here. So 1, this town which was not polluted is now polluted, and we get 1 here. That means this town is the last to be polluted, and second last column belongs to I. That means Isagopolis, and we can see that. Say it is connected only with G. The pollutants are coming only from G, and we can see that it is last in the line, so that's why it is polluting the last. So find which town is last to be polluted. Isagopolis. Write down the number of days it takes for the pollutants to reach, which is 4 days, right? This is after 1 day, this is after 2 days, this is after 3 days, and this is after 4 days, so 4 days. Okay. A sewer inspector needs to plan the shortest possible route, basically to inspect the route through each of the connections between different places, determine an appropriate start point. So you can see that the connection between F and other towns is only 1. So there is only 1 connection here. Isagopolis also has only 1 connection. So that means they are the ends. These two. So you can start from F or start from I. So what I can see from the picture here is, let's start from F, okay? Or yeah, F is fine. F, we can go to T. It is directly connected to T. Then we can go to H here. Then we can go to E. The inspector can go to E, and then to G, and finally to I. This could be the best route for him to inspect in the shortest span of time. This concludes the second question as well. There are only 2 questions in this exam. I hope you liked it. If you did, please give it a thumbs up and subscribe to my channel, and motivate me to make many more videos like this for you in future too. Thank you so much.